Okay, so now we want to talk about how our mountain belts formed in light of plate tectonics. And in doing so, we're going to find that you're going to see how that causes folding and then faulting. So we've already discussed plate tectonics in an earlier lesson. So this is going to be a review of some of the principles of plate tectonics. And then there's a few extra words that are associated with this that I want you to know. Okay, so in plate tectonics, there were three things that a plate could do. A plate could be pushed together, so that was called convergence. A plate could be pulled apart, that was divergence. And then plates could slide past each other, that was the transform. Well, transform plates, they don't really make mountains. Now they do fault though, so you have transform faults, strike slip faults as a result of that. So that's all I want to mention about transform faults. So let's now just concentrate on convergence and then divergence. So convergence is where the plates come together, and then there were three different examples of a collision. So you could have an ocean colliding with an ocean, you could have an ocean colliding with a continent, and then you could have a continent colliding with a continent. So let's look at those three different things in light of folding and faulting and what could happen. So the first one is going to be ocean-ocean. They're both composed of dense basaltic rocks, so both plates want to go down when they're pushed together, but the one that is going to be the colder of the two plates is the one that's going to go underneath the other one. So you're going to end up with something like this, and so one of the things you end up with is going to be a trench, and then when this plate melts, the materials the lighter materials from the plate come back up to the surface, and you end up with an island arc system. Well, so far that is nothing new. Okay, now we want to go a little bit further with this, and we want to show how it could also not only be compression. Okay, it's going to be compression where the two plates are coming together, but as this plate is going underneath, it's going to stretch the ground that's over here, so that you're going to have extension pulling apart behind the island arc system. Okay, and so that's going to be called a back arc basin, where material can accumulate behind that series of islands. Okay, the ground is being pulled apart back there. The asthenosphere material can come up, and so you can end up with new ocean floor forming behind the island arc system. Or the ground could just be pulled apart enough to where you have faulting. So notice that in front of the island arc system, you're going to have compression, so that could cause different kinds of reverse faulting, could be a result of that compression. But then on the extension side, you could have where rocks are being pulled apart, and then it's going to make a series of rocks that are going to normally fault. So this is going to be dip slip faulting, so normal faulting where the rocks are falling like that, and so that's where you could have that kind of activity going on. You could also have folding occurring. So as in front of the subduction zone, as the plates are being pushed together, that could cause some crumpling of the plate so that you could have some folding. So in front, you could have reverse faulting and folding, and in the back, you could have the normal faulting as a result of this. All right, let's take a break. When we come back, We'll talk about what happens when an ocean collides with a continent.